Hello everyone, welcome to this video. In this video, I'm gonna explain how to solve this. Explain the logic behind how we solve this arranging coins. Right? We have these coins. We are given a total number of n coins, where we have a staircase for staircase type of thing over here. Okay, so every k coin row, every kth row must have exactly k coins, and find a total number of staircase. So we need to find a total number of staircase. For example, when we read this question, we need to exactly try to print it out, right? So the example is the best way to visualize this question, because if you read this, it is like we're reading some kind of scientist, some kind of chemical equation or something. So leave it. So 32-bit size integer is like from -2 billion to 2 billion, right? So there is, I don't think we'll expect a number like even 1000. Yeah, we can have that number. So for the time being, we can use an integer value less than 10. Yeah. So here we have this visualization of this question. We need to form like a staircase type of thing. So if the staircase is not complete, we will return the like in the third row it should be like 1 2 3, right? If it is 3, we'll return 3. If it is not 3, we'll return the complete staircase. This is the complete staircase. We have 2. For example, like here 1 2 3, and here it's come 4. So since the fourth row is not complete, we return 3. So similarly, we have to do it here. We have to write a function that uh, complete this equation. So here n is the 8. So we have 1 2 3 4 5 6 7 8. Yeah, and even here 1 2 3 4 5. So n is this number of like what coins. Yeah. So let me write this question first. So k is the total count, right? Total count of staircase. Let me write this total count of staircase stairs. Okay, let me write it as 0 initially, and L is now let me say, now let me write the steps. Staircase steps. Staircase steps. What does it mean? Initially we start with 1. Okay, this is the first one. So then we have 2 3, right? So let me assign it as 1. So while n is greater than 0, so we have to have a value greater than 0, because uh, if we have a value less than 0, that means we can just return the stair as 1. No, yeah, it depends. We can have various number of conditions, but for a time being, there is like what, it is a non-negative integer, right? It is a non-negative integer. It means it is a positive value, so we can have a negative value if the condition was something else. So now we'll try to n minus staircase steps. Let me just copy this and paste it over here, and let me just paste it again, and let me just yeah, do this again. Like, I'll explain this slowly. So for the time being, I'll just put this one as k, because you know why, this is so long. I don't want to write these long steps, long words. I mean, variable names are so long. I'll just make it short. Yeah. And now what I'm gonna do is, if n is equal to 0, return k. Else, okay, let me just put a semicolon. Else, return minus k. Okay. So now let me just copy this, and yeah, let me just put this as co and as cons. Yeah, doesn't look nice. Var we're using let over here, and let me just go to here. So 32-bit size integer, right? I just want to just clarify this one. It's a yeah, we can see this value, 32-bit size integer. And non-negative integer, yeah, there is something like this, so we don't have to worry too much about the n value right now. And it should be just like a positive integer. And now let me explain this. First, let us assume n as 5, right? While n is 5, right? 5 is greater than 0. So 5 is greater than 0, right? Then we'll go here. N is equal to 5, right? We'll take n as 5, right, at the moment. Now n is greater than 5, so n is equal to 5 minus 1. So when n is 5, n is equal to 4, we have I is equal to 2, because I plus 1, 1 plus 1 is equal to 2, k is equal to 0 plus 1 is equal to 1, k plus plus, right? Now we have n is equal to 4 minus 2, because I is equal to 2. Now we have 2 here and I as 3, because 2 plus 1 is 3, k is equal to k plus plus, that is 1 plus 1 is equal to 2. Now we have n is equal to 2 minus 2. Yeah, since like first will be condition like while 4 is greater than 0, it will pass. Again while what 2 is greater than 0. So this is the third time. Okay, first, second, third, first, second, this is the third condition. Now we have what 2 minus 3, because I is equal to 3, we have minus 1, and I is equal to 4, k is equal to 3. So now it will be false, right? Minus 1 is not greater than 0, so it stops here. While loop stops here, so this is the final condition. So we have 1, 2 and 3. So this condition, at this place we see that we have I1, I2, I3, but I3 is not 0, so we have to delete minus 1. So 1, 2, 2. I'm gonna say this again here, 1, 2, 2, because 3 is not this part is not 0, so we have to subtract minus 1, 3 minus 1. Okay, 3 minus 1, 2. So now we are less than minus 1, so we cannot return the value of k. That means since n is minus 1, we have to return this value, that is k of minus, that is 3 minus minus is equal to 2. So let's see here, let's get this function Aaron's coin, right? A, and let me put the value of n as 5, we'll get 2. So we get here 2, right? Similarly for 8, 5, 6, we can change the value, and you can see, so for 6 it will be 3. See, for 6 we have 3, because at that moment it will be like 0 over here. So this is the logic, right? How we increment the number of stair steps, and this is the way we solve. So let me just pass this value. Run code, yeah, run code, run code, run code, run code. Okay, and it accepts, yeah, can submit. I've done this before but I'm trying to explain over here. So yeah, it corrects. So I hope your logic, I explain the logic behind this function and all, this while condition and this and that. So I hope if there is any questions you can ask me in the comments, right? So I hope you enjoyed this video, and yeah, I hope you have all your questions cleared, and any questions regarding to this arranging coins, right? And yeah, thank you, have a nice day.